I don't know if any of you was at the previous session, but what we did was detecting body poses in the webcam. You can see it a little bit in these two images. The webcam image is analyzed by ML5, and then it draws a skeleton on top of the webcam image. So it knows where your body is. And we're going to do that today as well. And we're going to add one step to it, which is seeing if this body has a yoga pose or not. That's what we're going to do today. We're going to use a neural network for it. And I think for all of you, really, if you succeed in getting the neural network understanding what it is and what it does, and even if it's just 10 lines of code, that will give you so many opportunities and so many options to use in your own projects, then you will have I made a big step today. So let's make that the goal. So just get the neural network running and let it learn something. If you can do that, then yeah, that's the beginning of a really cool process, I think. I'm gonna skip the next slide. This was about the previous session. What we're gonna do today. Step one is learning what a yoga pose is. And for that, we need the PoseNet model. You can see it on the left in this slide. The PoseNet model is something that already exists. We call it a pre-trained model. And some very clever scientists made this thing and put it online for free. So we can be thankful for them. And what this does is it looks at a photo or a webcam, and it gives you the location of a human body in the photo. So it's called PoseNet. And we'll see how it works in just a few minutes, I think. And we did that also in the last session. What we're then going to do is step two is we're going to get some images of yoga poses. It could be photos of yourself doing yoga, but it's better to use existing images so that we know what body pose is actually a yoga pose. So you can see those three guys on the left are just standing around. That's not yoga, but the computer doesn't know that. So we have to teach the computer what is a yoga pose. For that, we use a lot of yoga images in this case. And to teach that to the computer, we are going to use a neural network. And that's the right part of the slide. So that's our first big step. We are using data from, well, we can find data online. And we're going to use it to teach the neural network, okay, this isn't just some set of pictures, but this is a set of yoga poses. And the neural network is going to learn why is this yoga and not just some guy standing around. So that's the first step, what we're doing today. And the next step is the other way around. We're starting with the network that we trained in the previous slide. And we start with an image from the webcam or a photo. But now, because the network has learned what yoga means, it's going to tell us what this pose is. So there are always two steps when you use neural networks or models in general. The first step is always to train the model, meaning you give lots of data to your model, and then it learns what yoga is. And in the next step, which is what you see here, you do the other way around. You get the neural network, you load it, and you get some image of some person. You still need the PoseNet model because the PoseNet model finds bodies in a photo, and our neural network will tell us if the body in the photo, the pose, is a yoga pose or not. And that's what we see on the right. We will get a prediction. In this case, it says goddess 67%. This means that our model that we trained has confidence of 67% that this is a goddess pose. Please bear in mind that the skeleton that is drawn here is made by the PoseNet model. So that could be a bit confusing. That's why I'm repeating it a few times. We use PoseNet to draw the skeleton, and we use the neural network to say if this skeleton is a yoga pose or not, or what yoga pose it is. That's what we're going to do today. Is that clear to you? Is it understandable?
Super clear.
Yeah, it's clear. Okay. Then I have a question.
I will ask a question that I
Yeah?
actually know the answer to, but I think it will help to clarify it. Why can't we train the PoseNet to recognize, like if that recognizes the body parts, why do we need actually the neural network step for it to recognize?
Yeah, I don't know if you saw the slides already, but that is my next slide.
Okay, I did not. I will shut up.
Okay, no, that's cool. No, that's great. That's a very good question. Why would that be? Maybe you can try to answer it. Maybe anyone can. Why do we do that? Why wouldn't we just look at photos and just use the photos directly?
Because when also you are in front of a photo, you try to reproduce it. Sometimes you are not really like, maybe there are some little movements that you should do that are wrong.
Yeah, could be that the movement is not entirely correct. If you look at these photos, I picked 4 photos from a yoga set. And let's say we just give these photos directly to a neural network or to PoseNet. By the way, I don't think you can retrain the PoseNet. That's just not possible. PoseNet is actually closed source, strangely. But we can just feed these images to a neural network directly. That is possible, instead of the PoseNet pose. But let's just assume for a minute we just have these photos and we're gonna just give the images to a neural network, 2 planks and 2 goddesses. Should be clear, right? The left 2 are quite clearly straight, almost lying on the floor, and the other have very different poses, the goddesses. But there's still a reason that this doesn't really work very well. Can you try to think of a reason?
It will overfit on the background, like it will take in information that's not relevant, like the background or like the environment, how far you are from the camera, but also say these are all women. So maybe if David does this, it won't work on him or something. Like it will overfit on things that are not relevant. Or maybe if you're chubby and you do it, it won't work also because all these people are looking very fit.
Yeah, exactly. So in these photos, it might start thinking that goddesses are always outside in the sea, near the sea with the blue sky. And the planks are always people with white clothes on a white background. Yeah, that's exactly right. It could learn all kinds of stuff. Then a neural network can learn anything, which is great, but it's also a danger. In this case, it just gets way too much information. A photo contains so much information. Color of the grass, the one girl is sitting on a mat, the other isn't. You never know what it's going to learn. That's why we can use the pose data, which is very focused on one very small part of the photo, namely the actual pose of the body. And there's someone who made a list of neural networks that learned the wrong thing. I think it's very funny. It's a bit a boring list, but actually, when neural networks started becoming popular, they used it for any kind of thing. I'll paste this in the chat. And neural networks have actually learned so many wrong things. For example, here's one on mushrooms. They wanted the neural network to learn if a mushroom is poisonous or not. But it actually learned that in all the data, all the poisonous mushrooms were even numbered and all the edible mushrooms were uneven numbered. So there could be lots of, that's also called bias in data. There's a lot of hidden information in data. It can even learn when, airplanes landing the wrong way. I'm gonna paste this in the chat. Where is it? Zoom. By the way, do you see my Zoom? Oh, here it is. Yeah. Sims were. Which one is that?
I just saw a few in the rows are about Sims, and I played that so much, so that's instantly my favorite fail. Like create a collision detection bug to get free energy by clapping body parts together.
Oh, yeah.
Is this like a neural network that they try to teach how to play Sims?
I think so. Many games have.
Okay, I will look into this one.
Yeah, look into it. Yeah, this person is just called Sims, Carl Sims. But there are lots of cool. The whole point is neural networks can learn anything. It can be very interesting, but also not what we want. We just want a very specific data. That's why we use the pose. So instead of giving the whole picture, we give only the skeleton. And this really contains only the key points of the human body. And if we use that, we can be pretty sure that's only what it learns. So yeah, it could be a bit confusing. I think this is the most confusing part of the workshop, that we need two models. The model that gets the body poses, the skeleton, and the model that knows if it's yoga or not. But we're going to do these two things separately. I've been using the word neural network a lot, but I haven't really told you what it is. To really explain what it is might take a long time, but in short, it's just a mathematical function that uses cells called neurons. That's why it's a neural network. And it makes connections between the cells. And the way those connections are made it allows it to learn what data is. So it allows it to learn when a dog is a dog and when a cat is a cat. And you can do that in 10 million kinds of ways. In this case, it could learn that dogs are big and cats are small. So in this case, we have 3 inputs. So it could be the weight of the dog, the size of the dog, and maybe the color of the eyes, just to name 3 things. And then this network is going to learn when those 3 things make something a dog and when those 3 things mean it's a cat. And it does it by assigning numbers to all the connections. This is something you don't really have to know because it all happens invisibly. And especially in ML5, it's totally invisible. We don't even have to understand. The only thing we do have to understand is the input. In this case, there are 3 inputs. And it could be anything you want. So if you think the dogs and cats can be learned from weight and size and color of the eyes, then you're going to be your input. If you think, okay, maybe the length of the tail is important, then you just add another input. You could also do the color of the pixels. If it's photos, you could use all the pixels as information. So there's a million ways to do this. But only thing you really need to know is there's an input, you put something in, it's going to learn what makes it important, and then it will give you an output. In this case, a dog or a cat. And I've created a very small neural network that actually works, just to show you what's happening. And let's see if I can open it. We have some data here on the left about cats and dogs. We're using the hair color, the length of the body, the height of the body, the weight, the ears, and the fact if it has claws or not. And you can see that the last column in this table is called label. You're going to see this more often. The label is what it is, a cat or dog. And all the other columns are features of the cat or the dog. I wonder if someone already notices something in this information. If you look at the table, is there something going on here? Do you notice it? maybe not. If not, then let's run it. Here is my cat and dog neural network. It only has one cell. I'm going to train it. That means that the neural network is going to look into this data. It's here as well. And it's going to look when something is a cat and when something is a dog. Let's see what happens. You can see it's training now. So this is something that neural networks do. They start out with some random assignment, a random brain, but it's going to train itself until it learns when something is a cat and when something is a dog. The text is a bit small. I don't know if you can read this. Can you read the green part? This is readable for you guys? Do you see something happening? You can throw it in the chat. I'm going to reset it. Train.
That it defines if it's a cat or a dog using clause.
Yeah, exactly. So it's learning. It keeps comparing all these features of the cats and dogs. And it's comparing its own network with the actual data. That's called an epoch. And every time an epoch is finished, it knows if its own prediction was right or not, and it adjusts itself. That is what training is. It keeps adjusting itself until it finds the pattern that always gives the right prediction. So in this case, it keeps learning. And what it's learning, which I find very fascinating, is apparently those clauses are very important. And all the other stuff is actually not so important. And if you look at this table, you can see that it's true, right? Do you see why it's true? Why are clauses important? And can someone shout it in the microphone or on the chat?
Oh, the falses are dogs and trues are cats. I don't know, it's my first perception.
Yeah, that's true. Yeah. Cats have claws, dogs don't have claws.
Okay.
Yeah, that's well spotted. And I think that's what makes a neural network so interesting, is it finds actually that it is true. The neural network also found that the clause are most important. One thing you have to learn is the word epoch. Epoch means how often it compares its own prediction with the actual value. And you can see how the more epochs you use, the more precise the prediction becomes. So the clause becomes much stronger the longer you let it train. So we've learned a few words here. We've learned training. That means that the network keeps comparing its own predictions until it's correct. And the epoch means how often it does it. So this is really what a neural network does. It's not more than this. Of course, it can be a lot bigger. If you Google for neural network, I've made a really small one here. But if you Google, you can find crazy big ones. But they all do exactly the same. The bigger networks are just able to find more complicated patterns. So I hope that is a bit clear to you. We don't even have to understand this, but what we do have to understand. Where's my keynote? I do. Here. That neural network really helps us finding patterns in our data. That's what it does. I hope that part is clear for you. My computer is going crazy. Let's see why. Let's close some stuff. Yeah. Okay. So in other words, the neural network needs numbers as input. So in this case, we used the cats and dogs, the ears and the weight. And anything can really represent it by numbers, cats and dogs, but whatever you can think of. And in the case of the yoga, for those who were there last week, but if you weren't, I can show you right now. This is what our PoseNet does. If you classify a photo with PoseNet, it will actually give you these numbers. So the skeleton, the drawing of the skeleton with those circles on the wrists and elbows and the lines between is actually done with these numbers. So you don't have to draw the skeleton. It's just because it looks nice and we can see if the pose is correct or not. But what's actually happening is that we receive these numbers. I think it's really cool that it actually knows each body part. So you can see the left ankle has X value and the Y value. And a confidence. We're going to ignore that for now, but it's of course how sure it is that it's actually a left ankle. But there is an X coordinate and a Y coordinate for every body part. And that's what we're going to use for the neural network. So if we count, how many numbers would there be? I think there are 17 body parts. The nose is the only one that isn't left and right. So there are 17 body parts, and every body part has an X position and a Y position. And that means 17 times 2, 34. That's how many numbers we are going to use for the input of our neural network. So instead of the 5 numbers we used in the previous cats and dogs, in this case we have, how much is it? 34 numbers. And that's what we're going to do. Is that clear to you so far? Is the goal of today? Get the numbers from PoseNet and use them to train a neural network. No, nobody's screaming and crying, so I think we could continue. You might wonder, okay, we know PoseNet gives us the numbers, but how do we get the yoga poses? And there's actually a website called Kaggle. Feel free to open it now in your browser. Just go to kaggle.com and search for yoga. And there are actually quite a lot of different yoga data sets. Kaggle is a very fascinating website that has lots of data on everything you can imagine. And as you've seen, a neural network can learn anything. So that should already give you some inspiration, I hope. The obscenity list, okay, that's new. Democratic rights. Since anything is numbers, you can teach a neural network anything. So you can put anything you see here into the neural network and just let it learn when something is obscene or not, apparently. But we're going to learn yoga, so let's just type yoga. Yoga pose image classification. Yoga poses dataset. I think I used this one, but it would be cool if we all use different ones. Yeah, I use this one. I can put this one in the chat. If you download it, it's 300 MB. Then if everything goes correctly, you should get this. I got this, 2 folders, one called test and one called train, and it has 5 poses in it: down dog, goddess, plank, tree, and warrior. And if you look in those folders, you get tons of images of yoga poses. And the cool thing is that they're all quite different. So we can see they're all yoga poses, but the background, the colors, everything is really different. And that's actually good, because then we know we can learn under very different circumstances. We can also see there's a train folder and a test folder. And the reason they add this is that you can train your neural network with those images in the train folder. And then to test if it works, we use the images from the test folder. That way we can be sure it doesn't learn only the images that we used for training, because that's a big risk of using machine learning, that it only learns those exact images. And by having a test folder, we can see if that's true or not. If it works with these images as well, which has never been seen by the neural network, then we know that it works. Again, the goal of today is not so much the scientific part of neural networks, but just to get it working. That's the goal. I think we should get to it as fast as possible, but let's make one little side step, which is this. If you go to ML5, for those who haven't been there, this is the URL. I'll put it in the chat as well. And you can see that it has in the reference lots of different projects, ML5 projects. We are using the PoseNet, and we're going to use the neural network. I circled a few others that also work with the same concept we're using. Instead of using body poses from PoseNet, you could use hand poses and learn something from your hand's position. Or you could use the face mesh or the face API, which learn your face expression. So PoseNet is good for yoga, but if you want to learn sign language, for example, you could use the hand pose and then learn all kinds of hand positions. So there's lots of options, even in our way we're working now. You could use face API maybe for seeing if someone falls asleep behind the wheel. Just train the network with lots of awake people and lots of sleeping people, sleeping faces, and then you can learn, detect if someone falls asleep. So there's tons of options, really. Okay. I'm going to dive into some code. If the whole concept and goal of today is clear to everyone, we're going to slowly move towards the code. If you are ready. I'm starting with some pseudocode, which means this is not actual code, but this shows the main concept. And the main concept you have to always keep in mind, because if something goes wrong, it's mostly related to this. The first pseudocode is where we add data to our neural network. And these numbers represent the pose. So those are the XY coordinates of all the body parts. And a label. So in this case, it's an array of numbers, and there is a label saying what it is. So we add the numbers 422567, and that's a goddess. And we're adding 64211, and that's a tree. Then we tell the neural network, okay, now you know all this, now you can train. And when training is finished, we can say, okay, now I have a set of numbers, but I don't know what the yoga pose this is. and then we're going to classify. So one thing that to bear in mind, if it has trained with 5 numbers in this case, then you also need 5 numbers to classify. And that means it's going to see which of these poses are most close to these numbers. So it will be a goddess or a tree. So this is what we're doing. In very generally speaking, we'll add some code to this and some JavaScript difficulties, but this is what we're doing. And one thing that's really peculiar about JavaScript, and some of you have struggled with this, even myself when I started with JavaScript, is that JavaScript does not really have a top-down order. So if I look at pseudocode, this goes from top to bottom. First you add, then you train, then you classify. But in JavaScript, it doesn't work like that. You have to make functions, and then you have to tell the neural network in this case when to call the function. So this neural network is going to train for 12 epochs. I hope you still know what an epoch is. It just means how often it's going to compare itself to the desired result. And if that has finished, so if the training finishes, we don't know when it will be, but if it does, then this finished function is being called. And this is a callback, and this is very often used in ML5. ML5 uses this a lot. So this is something, yeah, you have to get used to. You have a function, this has a name, and you have to use the name to tell the neural network what to do if it's finished training. So why is this important? The reason that it's important is we cannot classify when the training has not finished. Then you will get an error. So if you try to classify, but it's still training, it doesn't work. So we have to wait till training is finished. That's why we create a function called finished. And then we can do classify. And you can see here that classify works the same way. If classify has finished, then this function will be called show result. That's also a function. So these functions, you just sit around and waiting till someone calls them. The finished function will be called if the network has finished training, and the show result function will be called if the classify has finished, if this has succeeded. So that's, you have to teach yourself to paste all your code in a function, really. So you might even say that this first line is not correct because it's not in a function. So if you want to fix that, we would do this. Just put a function around it, give it a name, function start. That starts the training. And we have the function finished and function show result. And here at the end, we say, okay, now we have all our functions. That's fine. Now we call the start function. You can see it by using the word start with 2 brackets. And then we actually start the program. So this is what the JavaScript program looks like. It's always a lot of functions, and you have to decide when a function is going to be called. I think this is the part where most people struggle with. Sometimes you try to classify something, but training has not finished. And then you get your very annoying errors. Same with the show result. You have to wait till classify has finished before you can know what the result is. So maybe just tattoo this on your arm or print it out and put it above your desk. This is just, yeah, this will be the source of most errors, I think. This and just syntax errors, typing something wrong. All right. Are there any questions about this part? Does it make sense or is this confusing?
I think it makes sense. The only question is, where should we write it?
Yeah, I'm going to show you where to write it down.
Okay.
I have 3 slides and then we're going to type it actually. Right? Okay. So this is the callback structure. I just want to show you the actual code. It has a few more things in it, but that we just need for actual ML5 machine learning. So this is the full code. If you do this, you can train a neural network. So what happens here is, in this case, we're going to use a CSV file. That's what most data science uses. And if you go to Kaggle, you'll find lots of CSV files. A CSV file just contains data. In our case, it should be data about poses, but it could be anything. It just contains all the XY coordinates. Then we're going to make the neural network. And this is cool because it just loads all our yoga poses from a CSV file. And it says, okay, when you have loaded it, call this function data loaded. There we go. There's a function data loaded. Here we're going to train the neural network. So this is the actual code. So you could copy paste this, but I'll do it for you later. It says, okay, I have a neural network. I'm going to normalize the data. This is just a step you always have to do. Then you say, how many epochs do I want? 32 is a nice one. You can ignore the batch size for now. I think you can leave it out. And then you start training. If it's finished, you call the function finish training. And then we're here. We're going to save the model. That's what we're doing. The reason we're going to save the model is that we don't want to train every time. We want to classify a yoga pose. We want to train it once. We save the model. And then we never have to train it again. So you can throw away all the yoga images. Training is finished. So this is training. And then classifying, you have to load the model that we trained. This is the last part, by the way. You load the model that we trained. You can see that here, load a neural network model. The model has 3 files. You will see that later. You just have to load all 3. And this means, okay, we can finally get a new image, some new yoga pose, and ask the model what pose it is. And that's what we use the classify function for. And this will give us the result in the console. So this is all the code. Yeah, and I can understand if it's a bit overwhelming. At the same time, it's just 2 pages. And the training is like 10 lines of code, and loading is also 10 lines. So yeah, and 5 lines are the actual loading. So once it's loaded, we only have 2 lines of code to test if it works. So I think we can do it. Let's just do it, okay? I have one. I'm going to paste this URL in the chat. Yes, okay, thank you. It looks like this. We're just going to practice what I just explained. Yes. Can everyone open this URL? We're going to start with this one, the part 1, training a model. I can paste this URL too. This is what we're going to start with. If you scroll a bit down, it says remix. That's what we're going to do. So this will cause you to get your own code editor. And you can work online in your code. And you get my project as a starting project. So I'm clicking remix. Now it's making a new one. The cool thing is, you get your own URL, which is this. And you can actually share it with us. So even if you get stuck, you can put your URL in the chat and we can look at it. So we can all look at each other's code. And what we're going to do here is just practice the neural network. And we're going to use the iris dataset. And what is iris dataset, you may ask? It's a dataset about flowers. It's very famous because it's very simple and short. No, this one. It just has data on flowers. You don't even need this code. There must be a better. Yeah, there we go. It has data on 3 flowers. And we're just going to learn to recognize the flowers based on the data. Just to learn how the neural network works. You can see the data here. If you click iris.csv, you can actually see it. So these are all data points of different flowers. Sepal length, sepal width, petal length, petal width.
But is the one used by Refik Anadol in his project?
Sorry?
Refik Anadol, the artist, used for a huge amount of time, like a flower dataset. Is, for example, this one of that he probably used?
Could be. I don't know if this, but this dataset is very famous because it's so easy to use, and it's open source, of course. And it's just, yeah, it's just these 3 flowers.
Okay, super cool.
Yeah, so let's try it. So we're going to teach the neural network that those numbers are iris setosa. Those numbers are the iris versicolor. And those numbers are the iris virginica. That's all it is. Just 3 flowers. Each has their own number. Just for those who haven't used ML5 at all, let's start at the beginning. You have index.html, and that's also what you see here. So this is just the HTML website. If you know HTML and CSS, you can actually edit this. So when you edit something here, I'm training a model, then it will appear here. Sometimes you have to put refresh. This is your website. If you want to see the website in full screen, you can click here. And you can say in a new window. Then you get the whole website and you get the URL. This you can share with us. And you can edit the CSS actually if you want. This is just the colors and the fonts. So your design stuff can go in here. There's also a message here that says loading. We used it in JavaScript, so we can put something else here instead of the word loading. That's why it has an ID. Now this line is very important. This line actually loads ML5. Without ML5, we can't do anything. So this script line loads the ML5 library. You can always put ML5 in a separate window. Yes.org. And this will always give you the reference. In this case, we're going to try the neural network. So you can always open this in a separate window just to get the description. We're going to do almost exactly what it says here. Okay, then there's a line that says load the script. That's our script. And that is this file, script.js. I think, I hope this is readable for you. I can make it a bit bigger. You see some code in here, but not a lot. You can see that the first line is actually getting this message here, the loading message. And that just allows us to put something else in there instead of the word loading. Then there is a second line. This is a variable that we are going to use for our neural network. You can call it what you want. You can say my neural network. Maybe that's clear if you change it. Then there is the start function. This is what I explained in a few slides ago. We're going to call this function when our program starts. And you can see that all in the bottom somewhere. You can't see it anywhere. It's not doesn't start, so we have to type it. That's cool. We're going to do that. Once it starts, we get these options. Hey, we are going to tell our neural network there is a CSV file with the flowers. We're going to tell the neural network, hey, these are there's actually 4 features of the flower. And there is a species that is the name of the column that has the actual species. We're also telling the neural network that we are going to classify, and that means we want to know what kind of flower it is. It's called classification. We also have this line that says debug true. That just means we're going to get a nice little graph showing if it's actually working or not. So these are our options. I gave this neural network the name my neural network, and we're going to use that. So here we're going to say my neural network is ML5.neural network. And then we have a neural network. It's almost magical. We're going to give these options. So here's the word options. That actually refers to this whole block of code. So it knows where the CSV file is and it knows what it has to look for. And then this is the callback function. This means that once it has loaded this, it's going to call the function data loaded. So you could try this right now, actually. It says message inner HTML is finished loading. So once it's loaded, we should see this message here. So we can try it. Oh, and probably nothing will happen because the start function is never called. So we have to do that somewhere. If you get an error for the NN, just comment it out. We're going to type start here. You can do it anywhere, but I think at the end is the best. This means all this code is read, then the start function is called. And when the start function is called, all this code will be executed. And when this code has finished, then this function will be called. And right now, all it does is change this message here. I'm going to see if it works. Yeah, for me, it works. Apparently now this, yes?
No, for me too as well.
Sorry?
For me too as well.
Okay. Okay, cool. That's good to hear. So this means we are actually here. So the CSV file is loaded now. We're going to normalize the data. This is just something you have to do. My neural network dot normalize data. You can use the name that you also use here. Then we have the training options. This one is the only important one, the epochs. This just means how long you want it to train. Yeah, you can fill in anything you want here. And then we're going to actually train. So this is the most exciting part. We're also saying, okay, start training, use these options. And when you are ready, call this function finish training. And we can see if it works already. So I'm going to try it. First loads, yeah, okay. Well, this is very cool. This happens because we set the debug to true here. Now it starts to train it starts to find data in the CSV file. It starts to find a pattern. So it's learning what flowers are what species. And the goal of learning is to make this line as low as you can. And we can see that it has used 32 epochs now. It stops at 32. And if you want, you can try to make it longer, see if it learns more. Yeah, so maybe that's good. Just let's everyone try to put a different number of epochs in there and just see if it's better or not.
But it's possible that mine is still loading.
No. So if something is wrong with your project, you can share your screen, I think. I think if you put this URL, then we can see your code. If you put this in the chat.
Because I think I didn't change almost nothing. I mean, I changed what you show, but
yeah. Yeah, so if maybe you didn't call the start function here at the bottom.
Maybe it could be. Wait. Okay. Okay, I finished loading.
Cool. Okay. Yes, you finished loading. Okay. And then the training has to start. Did you get that part?
Yes, start training.
Do you also see this graph?
Not yet, but they told me to remove. Okay.
Yeah, someone says uncomment the const before neural network. Yeah, on line 18 it said const here. That's my mistake. This should not be there.
It says that there is a start training.
Start training, okay. This is your project. Finish loading, start training. Okay, then here you have to uncomment this.
Okay, so I think I did it.
Yes, so line 29 you have to uncomment. And also remove this const here on line 17.
I remove it. This one and then.
Yes, that's cool. We can see you typing actually.
Okay, now it's working.
Yeah, this is nice. We can actually see what you're doing.
Okay.
This is really funny. Your training is really different than ours, but that's cool. You can try to do a few more epochs on line 25 and see what happens. Yeah, maybe, yeah, 40.
Oh.
You want the line to become as flat as possible, very low. So you can see it's not learning so much anymore after 0.4.
Like that?
Yeah, yours is very erratic. That's funny. It's very different. See how strange this line is. 60, okay. Wow, it's all over the place.
But in my screen is different.
Yeah, it's not getting much better. It's very you don't get much better than 0.4. Well, okay, it's not great. It's working. You could try even more epochs just to see if you can get a lower number. In my case, it's 0.2.
Sorry, why this happen if you're using the same data set?
Yeah, good question. Why is it not exactly the same? The reason is that the neural network always has a random starting point. I think when I showed you the cat-dog data, the experiment, let's see if it's still in my history somewhere. Localhost. No. Okay, I have to find the slide. Okay. So this is a baby neural network. You can see the start position are the connections between the cells, and that's actually random. So right now the length is negative, the height and weight are a little bit positive, and the ears are a bit more positive. But if I reset it, it's different. So every time you start a neural network, all those connections are randomized because it doesn't understand anything about cats and dogs or flowers. And every time you train, it tries to correct itself. So that's what's happening inside the neural network. And that's why it's different for all of us. Also, our computers are different. We have different graphics cards and different speed of CPU, so, different randomizers in the computer. So actually it will be different on every computer you try it. Even for yourself, it might not work as nice the next time you do it. So sometimes you have to train several times until you get a really good graph, and then that one you save. So yeah, there's a lot of randomness. But it is a bit strange if some of you never get good results and others do. It could really be a hardware thing. But you can try to improve epochs. I always get around here, 0.2 apparently. I can do a bit more, 64 maybe. Oh yeah, it gets better. Yeah, that's cool. So in my case, 64 is actually better than 32. Okay, let's not hang around here too long. We only have 1 hour left. So what we want to do here, after we are finished training, so now the computer knows when a flower is a flower, we can do two things. We can just test if it works. So that's called classifying. Let's just do it. There is already a function called classify. We only have to call it here when the training is finished. So you can say classify. And it's expecting some input. And the input has to be 4 numbers because the CSV file has 4 numbers for every flower. So let's just copy one from here. That should be, I'm copying the second one, the second flower, Iris setosa. Let's just give the network its own flower back. And let's see what it thinks about it. One thing that's important is how you write it. You have to put square brackets around the numbers. So classify function is called. We put square brackets around 4 numbers. You can put any 4 numbers you want in here. That means this function is called classify. We uncomment this and we tell the neural network, my neural network. to classify it. And this handle results is going to log it in the console what the result is. And if you want to see it, you could also put it in the message. Message.innerHTML is, and you could put this whole line in there. Okay, so what I've done, when the training is finished, we get the message, hey, you finished training. Then I'm calling the classify function with 4 numbers. In this case, it's a flower. Then the neural network is going to classify that flower. It's going to call the handle results function when it's finished. And then the result will be put in the message. So I'm going to try it. I'm going to use a bit less epochs actually, just because it takes too long. I'm just going to use 12 epochs. It's very inconsistent. I'm going to try it out. Loading, finish loading, start training. Only 12 epochs. And then it says, hey, it's an AIxDesign with a confidence of 0.95. If you got this working, then you actually have trained the model and you are able to classify data.
Sorry, can you roll down your code? I lose the last part to write on mine. The message inner HTML. Results. Okay, label confidence at the line 51.
Yeah.
Okay.
I put everything in there that's also inside the brackets of the console.
Sorry.
Yeah, that's fine. If you want to see the whole result, it could be interesting. You can also do just console.log result, and then we see everything that the neural network is thinking. Let's just do that. I'm going to refresh it again. You can already see why training is a bit annoying, right? It takes a lot of time every time. Now it's finished training. If you want to see the console, you have to right click and then go to console here. And here is our actual total result. It gives us 3 confidences because it knows that there are 3 flowers. But the AIxDesign has a confidence of 93%. Versicolor 5% and the other one 0.002%. So that's the complete result of the neural network. If this is working for everyone, I think it's a bit, I hope you agree, it's a bit annoying that every time I want to test a flower, I have to train this network. That's annoying, so we don't want to do that. We want to save the model. So if we're happy with our model, let's put the batches epoch to 32. Instead of classifying, well, you can classify it, but I'm also going to save it. And that's super easy with ML5. You can just say save. My neural network.save. That's it. Now it's going to save it. This is what those scientists have done with the PoseNet. They just kept training the PoseNet until it was really perfect. And then someone pressed the save button. So I think it's pretty cool that we can do this ourselves. Okay, I'm going to try it out. Hopefully the last time we have to look at the training. Yes. Oh, I think it doesn't work if you have it in this small window. I think you have to run it in its own window. Okay, gonna try again. Yes, it asks if I want to allow downloads. I allow it. And now it's going to download our model. So this is pretty cool. Now you have your own model that can recognize flowers. And the model has 3 files, the meta.json, model.json, and the weights.bin. It's a binary file. Does that work for everyone? Are you able to save the model?
Yeah, but I'm not able to see which flowers he's checking. I don't know why.
Okay. You can put your URL in the chat if you want. Then we can look at your code. You can just put this URL. Yep. The mature standing droplet. Okay. Training. .32. Yeah, it's even downloading. So that's working. But you don't get the message.
Yeah.
Okay. Okay. But you do get finished training. Classify. Okay, we can look in the console. Well, what's this? Oh, you do get a result. Yeah, it does work.
Ah, okay, just doesn't print.
No, so if you, yeah, if you want it in here, then you have to use this message.inner.html.
Ah, okay. Yeah, I have it.
Yeah, you do have it. So that's a bit strange.
Okay.
Maybe there's an error somewhere. Yes, result. Oh, there's just a typing error. See, it has to be all caps. HTML has to be all caps.
Oh, okay.
Okay.
Yeah, now it works. Oh,
okay, nice.
Yeah.
Okay, that's cool. Iris confidence, 0.98%. That's very good. Okay, cool. All right. If everyone has this part working, we can go to part 2, I think, which is loading the model. Actually, time is going much faster than anticipated as usual. Yeah, what we could also do if you want, now I'm just going to part 2. Yeah, let's do that. I'm closing this one. I think it's auto-saved. The caterwauling serotonicus. So this code should still work. I can close this one. We're going to part 2. So there's the workshop ML5. Part 2, we're just going to load this model. So this is part 2, load model. It's almost exactly the same, but we don't have to train. So I click remix another. So if I look at the script, you can see it's almost no code anymore. We make the neural network again, but now we are going to load the model that we already trained. And the rest is just exactly the same as what we've been doing already. So all you have to do is put the model online somewhere, and you can do that by uploading it here. You can upload a file. I'm going to try it myself. So the model that I trained, I think it's in downloads. I hope, yeah, model.json. Yeah, those three, model meta.json. Upload model JSON and the bin file as well. Now something strange happens. For some reason, those JSON files are just put here. This is something that has to do with glitch. Glitch is very cool, but I don't understand why this happens. But it's no problem. The bin file ends up in this assets folder. And if you want the URL of the bin file, you have to click it. So this is the URL of the bin file. I'm going to copy it. And then all we have to do really is put those three URLs in here. So the model is model.json. The metadata is model meta.json. And the weights is the URL I just copied from the assets folder. So that's the really crazy URL. It looks like this for me. So now we're telling the neural network that there is already a model. Just has to load it. And when it is loaded, we are at the same spot we were, so we can classify. I'm going to try it right away because it's the same. We need 4 numbers in here. I'm going to come up with 4 completely random numbers. Let's see what flower this is. 2, 3, 5, 7. And let's also put this in the inner HTML again. So message inner HTML is this. I'm going to try it out. I'm not. Let's see. Yeah, it took longer than I thought, but it worked. Confidence is 1 that it's an Irish Virginica. That's crazy, but it's working. The model is loaded. Let's try a different number. Just to see what happens. The model is being loaded. It's a bit strange that it has a confidence of 1, to be honest. Mostly it's not 100% sure. Yeah, okay. This is a bit weird, but it might be due to this glitch environment. Is this working for you? Have you been able to load the model that we trained?
Yeah, I was able, but so I'm a bit late trying to make my flowers run now. I don't know what I missed. Oh, I put the models, metadata, wait. Where did you get the numbers for the classify?
Yeah, I just made something up. I know it has to be 4 numbers.
Ah, okay.
But if you want to do it correctly, you can find 4 numbers in the, oops. No. In the CSV file.
Ah, and the other one.
Yeah.
Okay.
So I'll just get some numbers from the CSV file from part 1.
Yeah, I'll try now.
I actually have it here. Got one here. This is from the CSV.
Mine has been stuck on classifying for a while, so I don't think it's working.
Okay, you can show your URL.
Yeah, I did train a bit differently because I skipped ahead and did yoga instead of flowers.
Okay. Cool.
So I should have like 32 key points and stuff. Other than that, it's practically the same.
Yeah, that's true.
But yeah, I shared my link, and I don't know why it's not working. Did you change? Oh wait, maybe it's really dumb. Maybe it's just in my console instead of in my HTML.
Yeah, that's what was my.
How do I?
Yeah.
Oh, okay. How do I open the console on Glitch?
Yeah, you can right click.
Just regular console. Yeah.
Yeah, and then inspect element. This is Safari, but in Chrome, yeah, you
yeah,
don't.
It's the same. Yeah, it's the same.
Inspect, and there's the console. And you get a better console if you do show here in new window, because otherwise you all get lots of messages from Glitch, which actually has nothing to do with your project. So if you do in a new window, you should see the console here.
Like this.
Yeah, in your case, you also don't have the inner HTML message here on line 32.
Yeah, exactly. So that's why it's not showing, but I don't know.
Yeah, but you can copy paste this one. Message inner HTML is, and then just put this in there. But this is your project, right? So I think we can see if your project works. That's quite cool, I think.
Yeah, I'm not getting a clear thing from console. Yeah, there's just so much stuff there. I don't understand where to look.
No.
Like the console is just completely cluttered. I don't understand which part to even look at.
No, it's this part, and what this says is that your number of elements is not the same.
Okay, well, it's also because okay, so yeah, here's a question, I guess. So when you train the model, there is 34 key points plus 1 label.
Yeah.
right? And then when I
Yes.
do classify now, I don't put the label.
That's true.
So there's 34 numbers, but no
Yeah.
label.
Yeah.
Well, it seems that it's giving me shit about that, even though that makes sense. I don't.
Yeah, I think you did it correctly. This should be, if you use the yoga CSV, right?
Yeah, exactly. Yeah, I literally just copy pasted it from there and then only removed the label, which
Yeah.
obviously I shouldn't classify the label. So I don't understand why it's not working, or if it's something else, or if I don't know.
Yeah, something went wrong somewhere. So
Yeah,
this error means
maybe
that
it's in my training though.
yeah, this error means that it's expecting 135, but you give 36. So there's maybe just one number
Yeah.
too many.
Actually, I think I know maybe what I did wrong. So when you're in the training file,
Yeah.
and it says something like options, inputs.
Yeah. Oh, you can.
Do you put the label there or not?
No, I'll show you mine. I have a finished one here. Let's see, where is it?
Yeah, so there you put only the inputs and then the label in the output.
Yeah.
Okay,
Maybe,
yeah, I think that's what went wrong. I'm gonna fix that and try again.
Okay. Yeah, I think it was in the comments, but this is how you can do it for the flowers.
Yeah, exactly. Yeah, you have input for and then output species. Yeah. Okay, I'm gonna fix that and export, train again and export again and see if it works then.
Okay. Cool. Yeah, so what Nadia did was, I'll show it to, I think maybe more people noticed that there are already data files for the yoga poses in the part 1 training model. I'll open it again. This was part 1. So I think if you got the model working, then I think you have already learned a lot today. Even if we stop here, you have learned to create a neural network. You have learned to train it and then load the model and classify new data. I think that's incredibly powerful already. So if you got it working to this point, you can really pat yourself on the back, because this is just so useful. You can use it for anything you find on Kaggle. So I think it's mind-blowing, to be honest. When I did this the first time, you can use it. Yeah, the obscenity list. I have to look at it, sorry. What is this? It's like, okay, that's maybe not a good idea. I shouldn't have done it. But it can classify obscene words. So it could be useful in a chat room where you can automatically filter people out who use obscene words. And you could use the neural network to learn what is obscene and what isn't. Pollution, deaths, pollution, danger, how. And one that is very often used for machine learning is the IRIS dataset, but also there's a Boston housing. It works very well. It's to predict house prices, Boston housing dataset. And it's also quite relevant in this day and age when housing is becoming unaffordable. But you can use anything, because all data is always numbers. It's a column, it's a lot of columns, and all columns have a number. And then there's a label. In this case, the label is the price of the house. So just with what we've done up till now, it's an incredibly powerful tool, I think. And it's just a few lines of code. So I think, yeah, maybe you don't realize it yet, but that's crazy. So here, this is part 1, the train model. There is a yoga CSV file. Nadia already trained her model with the yoga poses. I'm just going to show you how I made this CSV file. I think that would be a good place to stop this workshop. Otherwise, it might become too overwhelming. I'm just going to show you how I made this. So,
excuse me.
Yes.
I have a question.
Yeah.
My model, it works, but I don't know how can I upload my models.
Okay. Yeah, you can do that here. Write new file. And there it says upload a file.
Ah, okay. Upload this file or upload a file?
Upload a file. This one, I don't know if you can see my cursor. Upload a file with the arrow up.
Yeah. Yes.
And then you can upload them one by one.
Ah, okay. And in the script, in the weights.
Yeah. Yeah, the weights, they disappear. They go into this folder. Don't ask me why, but the weights are placed in the assets folder. And if you want the URL, you have to click on it here. And then here is the URL. It's a bit hidden. So if you upload it, but you don't see it, that's because it disappeared into this folder.
Sorry, I share my monitor.
Yes. Okay.
Oh. I can't share my monitor because someone or somebody is sharing.
Yeah, but you can put this URL here. You can paste this one in the chat, and then we can look at your project.
Yeah.
Yes. The purple detailed turquoise. That's you. Okay. So you have the model meta JSON.
Yes.
That worked, but you also have to upload the just model.json.
Sorry.
You have to upload the 3 files, right?
Yes, I have a moment.
So right now you have not put the other JSON file.
What is this?
Yeah, there are 2 JSON files. So there is model.json and model meta.json. You need this one.
Okay.
You can upload it also with the upload button.
Moment, I sent you.
I have the same question. Where do we find
Okay.
the JSON files?
We've saved them in the previous project. So in, let's see, where is it? Part 1, train model. We trained the model here in this code, and there we said save. So here in this line after training, we said neural network.save, and then it gets saved.
If you open it in a separate window.
Yeah, that's true.
Maybe that's the missing step.
Okay, yeah, good point. If it wasn't saved for you, then you have to open your project like this in a new window.
Okay, they work for me. Thank you.
Okay, cool. And then the final part, if you have the model JSON here, your bin file goes here. So you still have to upload the bin file and the model.json.
This is my first part, and
Yeah, what do you mean?
I sent you a link for my first part.
Oh yeah, yeah. Okay, yeah.
Model.
Okay, yeah, this is correct. Yeah, this should be correct. So if I do this, I get this result in my downloads folder. I get these 3 files.
Okay.
So if you don't have the 3 files, you maybe you have to save it again.
I have found it.
Okay.
And then I put this this model in part 2.
Yeah, you have to put all 3 of them in the project.
Okay, where is my part 2? Here. So I upload the JSON in script in new. Where should I upload the model?
Here in your project is called purple detailed turquoise, right?
Yes.
Yeah, so you already uploaded model meta JSON.
Mm-hmm.
And then you have to upload the other 2 as well.
Okay.
So let's see. Yeah, this is my project. You can see there are 2 JSON files here. You can upload them here. And if you upload the bin file, it disappears a bit. It goes into this folder automatically.
Oh, I don't know. I have uploaded my new model, but in the sense there is nothing.
No, I don't see it either. Maybe I can join you. I can request to join your project, I think. I have asked you to join. You have to approve, I think.
Yes.
Okay, now we are working together, apparently. Try and refresh. Yeah, now I can upload here as well. So let me try to upload. I'm gonna upload my model. Might become a bit messy. Model meta. Oh, it did already exist. I'll overwrite. Then upload a file. Model JSON. That's the second one. And now I'm gonna upload the third one, which is the bin file. Now there are here all 3, see?
Yes, I have sent this.
Okay, cool. And then here you have to put the URLs. I can type it for you.
Okay.
That's funny that we can work in the same project. So here you say model.json. And here we have to put this URL from the assets. You can copy it. And then we paste it in here. Oops. Yeah. That should be it.
Okay, thank you.
Okay. Well, let's see if it works. Model loaded, start classifying. Let's put it in the inner HTML as well then. So that's message.inner HTML. That's how you get it into the browser window. Yeah, it works.
Okay, thank you.
Cool. Right. Okay. What was I saying? I wanted just the last part of the workshop. I wanted to show you how I got the yoga data actually. So Nadja already found out you can use this yoga data to train a yoga model. So then you know if a pose is a yoga pose or not. That's completely the same as training the flowers. I even put in the bottom of the screen of part 1 the options for training the yoga. So there's already yoga CSV and the inputs and outputs. So you can train a model for recognizing yoga poses. I'll just show you how I got this CSV. So I'm going to make it actually. So we're going to go to part 3, extracting the pose key points to create a CSV file. We're going to remix one. I'm going to paste this one in the chat. Part 3, key points. Remix another. Enormous fossil attempt. So this is actually the PoseNet. We haven't even seen it today. What this thing does, it loads the PoseNet model and it draws a skeleton on the image. And you can actually upload any photo. You can do it right now. And if you downloaded the yoga photos from Kaggle, you can choose one of them. I'm going to do it now. I'm going to choose a photo. To find them, AIxDesign Workshop 2. To be honest, not sure where I put them. Yoga poses, I think. Yes. Well, you can put anything, goddess, any image. And this is pretty cool. It loads the image and the PoseNet draws the skeleton on it. So the red lines you see are the pose that is detected by PoseNet. So that's a different model than our flower model. This model is just good at finding a body in a photo. I'm going to do one more. You can also see that some are quite erratic, like the left feet is not correct here. It's always better to find a few that have correct poses. Wow, this is actually correct, even though there's a child in the image. That's funny. I'm going to show you how we can get these poses from the script, from the PoseNet. And I think that would be a good point to stop the workshop. So let's look at what is happening in this code. We see a few things going on. A lot of it has to do with PoseNet and drawing these red lines and red circles. This part just means we have red lines and a line width of 3. You can put anything you want here. We can make it blue if you want, with a bit thicker lines. It doesn't really matter. It's just to show where PoseNet thinks the body parts are. Here we load the PoseNet. So this means ML5 already has a PoseNet. If it's finished loading, this function is called. And this part means every time the PoseNet finds a body in the photo, it will put it in this variable called poses. So we have to remember that this variable poses, if there is a body in the photo, then this variable will contain all the key points of the body. This part, all it really does is create this button for us so that we can upload images. So that's what happens here. After an image has loaded, it's going to scale it down because all the images have different sizes. That's a bit annoying. All this does is make them all the same size. This is, by the way, a very big problem in machine learning, that your data is just a bit messy. In machine learning, you will spend a lot of time cleaning up your data instead of programming. And this is just a way to fix the fact that all the images are very different in size. And then we're going to find the pose in the image. By the way, if you think, how did Erik find all this code? It's just here, ML5yes.org. Reference, and you go to PoseNet here. So this one. This has all the example code, how to find the pose in the image. So this is just what we're copy pasting. We're not doing anything different. I put it in the chat. Okay, so here we have a button that loads the image. Then we go to the draw function, which draws the image. And this fill rect just makes a white background. Then we draw the image. Then we check if a pose was found in the image. And this poses is an array of poses. If it has more than 0 poses, then we're going to draw them. And there are 3 functions. Draw key points, which is this. This is straight from the ML5 website, by the way. This looks like a lot of code. It's all about these 3 lines. This is draw a circle. Where do we draw a circle? At position X and Y of the key point. So these are all key points, the knee, the ankle, left ankle, right ankle. And all these key points, left elbow, right elbow, have an X and a Y position. And that's where the circle is drawn. So the circle is there anyway, but we can draw it just to make sure that it's correct. So the machine doesn't need this function, but it's just for humans so that we can see where the points are found. The skeleton is the same, but it draws lines between the points. So this one actually gets the same data, but it draws lines. So we don't have to do so much here. Everything is working. All we really want is to get these positions, the X and Y position, because that's our data. So let's see if we can do that. There are several ways to do it. We could just put it in here. Let's just put it in the console. Maybe that's a good idea. I already created a function, log key points. We're gonna just log the console what our key point is. Let's see, how much time do we have? 10 minutes? Can we do it in 10 minutes? Log the key points in the console. Let's see what happens now. I'm doing it in a separate window, so the console is a bit clearer. Here is our pose. That's interesting. You can click the tiny arrows to look inside. You have to click again, and there we are. This is all our data. Apparently, it's inside this array in an object called pose. And it has key points. And there's a position in there as well. So there are several ways to find it. You could look at the left ankle, left ear, left elbow, left eye of the pose. But apparently there's also an array that has all the points. That's better for us. It's called key points. And we need the position. So now this is the first actual coding we're going to do. We're going to have to find those X and Y positions. I'm just going to create a loop that just loops through all the positions and adds up the X and Y. So this is just JavaScript. I think this is almost the same in any language. We're going to create an empty array that has the points. An array is 2 square brackets. Then we're going to create a for loop. The for loop is going to loop through all the points. I can copy paste this or even copy paste this, so you can type with me or just copy paste what I'm doing. This is my project. I'm going to create a for loop. It loops through all the points in the array. I know that there's an array of poses. I only want the first pose. For some reason, they put the data in another pose, so you can see that here. Okay, this is annoying. You can see there is a pose inside the pose. Don't ask me why. It's called pose again. Inside the pose is key points. So we're going to loop through all those key points. That's what I'm doing now. To check if that one works, you do console.log again. You can say key point dot position, because inside the key point is a position. Let's see if that works. Okay, that's cool. It actually works. It shows us all the X and Y positions of all the key points. I still need to go a bit further. I just need X and Y. I don't need the brackets around it. So what I'm going to do is I'm going to add to the points array. Add is called push. From the key point, the position dot X. And what I can do is round it off if I don't want all the numbers behind the comma. Math.round. Just to make it more readable. So now I just have X. I'm going to also do it with Y. And I'm going to log that part. Console.log points. Okay. So now we can try if that worked. It's cool, it worked. So now we have an array to put in our CSV. You can actually literally copy paste it like this. This is what I did. I copied it, create a new CSV file. Let's do it here. Create new file. Let's call it yoga poses data.csv. What you do is you have to create all the label names on the first row. Let's say left ankle, right ankle. I'm gonna copy paste this later, etc. And the label at the end. And here you can put the XY data. This is not good. There's still an array around it. It's a bit annoying. But you know what I mean. You paste all your data here, all your numbers. It looks like this. And in the end, you have to put the label. So in this part, it's a goddess. So that's in short, we could do it a bit more efficient, but this is a way to get all the point data from the PoseNet model and get it into a CSV file. I already did it, of course. The CSV file is here. I copy pasted all these names of all the points, left ankle X, left ankle Y, left ear, etc., etc. And the very important thing is that the end, the last one is the pose. It's a label. There you say if it's a goddess or a tree or a plank. And this is the first one that I got from an image. We can do it more. We can even put it in a message window. Maybe that's better. For copy pasting, it's easier if you put it in this window here. But I hope the point is clear of all this. You can use the poses and use the console. That's the most important thing, to find out what's inside those poses. And because we did that, we could find out that there are actually poses inside and that those poses have key points. So that's thanks to console.log. I'll reload it one more time. So in this case, we used PoseNet, but if it was the face API, something else would be here. So you have to read this, find out what kind of data you get from the model. And by looking in the console, we know what the data there is. We know that there are positions that have XY coordinates. And that's how we know how to write a loop, this loop. And there we could finally get only numbers. And because a neural network expects just a list of numbers. And yeah, I can understand if this is a bit much. At the same time, the learning point hopefully, is that the CSV file is actually just an array of numbers with a label. And that's all it is. And it can be a bit fiddly to get the right amount of data. You could, instead of creating this yourself, try to find if this data is already on Kaggle somewhere, and then train your model with that. Yoga poses, numbers instead of images, because so much data is already there. Now these are also images. All right. And Nadia, I wonder if you did you get your yoga model working?
Yes, in the yes, in that file where it loads the model and you put arbitrary numbers in. Yes.
Yeah.
Now I'm trying
Okay.
to get it on a picture. That's not yet working.
Okay. Okay. So you are at step 4, detect the yoga poses in photos.
I'm trying. Yeah, I'm at step 3.5.
Okay. Well, if you guys have some patience, I could show how far I got with this part. Is that okay, or do we want to quit? Just say what you want. It's 8, it's pretty late.
Yeah, exactly. I mean, let's see. I think it's quite a lot for me. I'm happy to like do, I don't know, maybe 10, 15 minutes just to see like the last step.
Okay.
But maybe, I don't know, can we have a quick like thumbs up, down, or in chat, what you guys prefer? If you would like to do the last step, or if you're like, my brain is spinning. Okay, I'm getting a few thumbs up. So let's just say if your brain is spinning and your stomach is going, then go do
I'm fine. I'm fine. We're here now, all right? So
yeah, that, I mean, if anybody wants to drop off, of course, you're free to. We'll send these links as well, so you can always look at it later when your brain is fresh again. In that case, thanks for coming, and for whoever, yeah, would like to stay till the bitter end.
bitter end until we all drop.
Yeah, exactly. I would like to see the last step just to round it up, you know.
Yeah, that's true. Yeah, of course. Yeah.
So yeah, let's see how far we can get.
Okay, so this last step, it combines everything. So it loads the PoseNet model, it draws the skeleton, but then it also loads the model we created. And Nadia is the only one who created the actual yoga model. But I created one for you actually, so you can load mine. And we are going to compare those two. So we're going to feed this pose into the model that we trained. And the model that we trained is going to say what yoga pose it is. So let's try how far we get. You can copy this practice again. Hello. Paste. Yes. Oh, it did paste. Okay. I'm also going to remix it. I think it's really cool that you can work together in the same code. So this is what we're going to do. Load yoga images to our key points. We did it already. We're going to add just this little step. So let's look at the script. It's almost the same as the previous one, but now we're going to add one little thing, which is loading our neural network. And this is the same as in the iris part 2. So that's what we're combining. So in the second practice, we loaded the iris data set. We created a neural network. But those few lines of code from part 2, we're going to paste in here. And I did it already for you. You only have to uncomment it, really. And then comment this one. That's quite important. So when this one sets up, it's going to create the red lines with the 3-line width. And then it's going to create a neural network. Here we have to put our model. I didn't put it here apparently, so I'm going to upload it. It has to be the yoga model. You can find it also in the other glitch. I think that I put the yoga model in one of the other ones, but I'll also share this URL so you can use mine. Yoga model, yep. Model data. Oops. Bin. Okay. If I share this URL with you, you can see my model and copy paste it or download it. You can actually use this weights file by just copying this URL. You don't even need your own. You can just copy one from my project. Okay. Or if you were able to train your own yoga, but these two you can copy paste, and the bin file you can just use this URL. I can even put it in the chat. So you don't have to upload your own bin file. Oh, it's here. See, I knew it was somewhere. It was here already. So you already have it actually. Can I join? Yes. You want to edit my code? There was actually a folder with the model. Okay, never mind. We have two models now. Okay, let's put the URLs here. Model/model.json, model/ what was the name again? Model meta.json, and the weights is the really crazy URL. Okay. Please uncomment this one because it's also here. And this means when the neural network load model has finished, the neural network has finished loading this model, then we're going to start loading the yoga model. So if you forget to uncomment this, it's going to do it twice. That's not good. So when this has finished, then we load this. And this is something you often see in JavaScript. It helps you keep sane. Just wait till the one thing is finished and then do the next thing. If you do everything at the same time, it can become very confusing. Okay, setup starts. It loads this one. If the yoga model is loaded, then the PoseNet model will be loaded, just so we can draw the skeleton. When the PoseNet model has loaded, it's going to pose this image. It already does that. It's going to draw it. It's going to log it. Let's copy paste the log from the previous one. I'll copy paste it in there. So we get all the numbers. Oh, it already does that actually. So key points. So I'm copy pasting it from the previous exercise. Let's see if that works. Save. Refresh. Yes, it works. What I've done is I've also put the numbers in this text field. It's called, this text field is called numbers, I think. Yeah, not a great name. So the numbers.innerHTML is this text field here, this white text field. And we put all the numbers in there, so that makes it very easy to copy paste. So what I've done compared to the starting code is I've added the model info. The model was apparently already uploaded. It was hidden in the model file. Then I'm loading it into the neural network, and that's all we really changed. The rest was already there. Then every time the image is drawn, the key points are logged in here. So that's all our numbers. And so the final thing we need to do is classify. And you can get the classify code from the second practice, but I'll just copy paste it in here. We gave our neural network a name. Let's see, what was the name? Just neural network. We can call classify neural network.classify. We could copy paste these points, but since those points are in this array, we can just say points. That's the same as doing this. Oops. I know that these are all the key points. You could put them in here like this. This looks more like what we've been doing so far. But those numbers are actually inside the points array. So you can also do this. And then you have to say, okay, what if I know the result? We have to call the function called yoga result. And that's this one. So we only added one extra line. We give the points array to the neural network to classify what yoga pose this is. I really wonder if it's going to work. Loading. That's not good. Probably have an error now. Yoga result. Not correct. Oh yeah, if there is no pose, it shouldn't do it. So let's say, yeah, that's a bit strange to be honest. I'm already checking if there's a pose. Okay, let's see if there's an error. Else. Result. Okay. Probably forgetting something now.
I'm not sure what I have different, but it works for me. So it's
Oh, that's great.
we must be close.
Yeah, yeah. Can you share yours?
Yeah, I've no idea, honestly, why why it works. Because I've just been typing along.
Yeah, okay.
It's very interesting, but
Yeah.
yeah, it does work.
Wow, I'm proud.
Thanks, me too. What was this to fixed that you typed after?
Oh, maybe that's what went wrong. Yeah. To fixed makes
Why did
the.
why did you do that? I missed that.
Oh,
part.
you mean in what line are we talking about? Let's see.
Like where you get the key points. So 178. Yeah, no, I don't have it there actually. So 118. You added there to fixed in the line.
Yeah.
I don't know what that did or what that was for.
That makes the number. Otherwise, you have 20 million numbers behind the comma.
Yeah,
That's all it does.
Yeah.
You can still
okay,
see
but
it
then
here.
because it seems like you do it now in the message rather than in the result.
Yeah, exactly. It's better to do it just before posting it in here.
Yeah.
Instead of doing it when you still have to
Yeah,
classify.
because it might need it also to classify, especially if it's
exactly.
like a similar pose. Like now we have just 4, but or 2 or something. But yeah.
Yeah, that's true. Yeah, let's try it with a different one because you can still upload images.
Yeah.
So I'm gonna see if a different one is
I'm gonna try a
collected.
downward dog.
Okay. Well, I only trained it. My CSV file only has goddess and tree, I think.
Oh, okay. Okay, so
it's either a goddess or a tree.
Yeah.
I was too lazy to put them all, but there should be some way to automate it.
I am gonna, I'm gonna really make this, I think. So I will continue your code and I can share it if people want that, but I'm planning to make it actually work.
Yeah, that would be great. No, you can look in the CSV file actually what I did. So
because now the CSV file, you did them one by one manually, but to make it, ideally you would be able to like loop through a folder of images and then just like append to something.
Yeah, exactly. This is not undoable to do it manually. I did 10 images, 5 goddesses and 5 trees.
Yeah.
In the real world, neural network model needs like hundreds
many.
of images.
Yeah, exactly. But it would be that because you don't have to really change anything about the code, right? Just instead of inputting an uploaded image, you input, like you make it loop through a folder or something.
Yeah, you have to make it loop through the folder and just say this, and you could even use the folder name as the label.
Right. Yeah. Okay, I'm gonna try that.
And you could even do that part in Python to create the CSV file. Nothing, because CSV is the same in every language. So if you have some Python script that can do that, then that's fine too. It doesn't matter.
Right, but I don't know how to.
But they can do it in JavaScript as well. You can load all the images.
I don't know how to mix languages or like.
No, that's fine.
Something from one file to another file in my glitch. I feel like it would be easier to look up how to do it in JavaScript than figure out how to send things across languages.
No, sorry. Maybe that was a bad suggestion.
No, it's a good suggestion, but I'm not that advanced. So, all right.
Either way, you need a lot of data to get a really, but the tree is actually fun. So I'm it's quite funny, I think. Let's try a different goddess.
Nice.
Yeah, it works. So I think that's pretty cool, even with so little data.
Yeah. I've also seen them doing this on video.
Yeah.
Like running on video.
You can do it on video, yeah.
How different would that be? Like you could basically use the same model, but then...
Yeah, it's completely the same. The only difference is you need to enable the webcam again, and we did that in the last practice. I can open it.
Also, for example, now it outputs something once when you upload the picture. But yeah, what if you would want say a webcam, you want it to live, so then it also checks all the time rather than doing it once, you know?
Yeah, I know. I'm showing. Can you see the code here? This is I actually made it with the webcam. The reason I didn't use it today, it's very awkward for me to run through my room while teaching you this, right?
Yeah, I can run through my room, I don't mind.
Yeah.
Yeah.
But it's almost the same. The only difference is that you have to also start the webcam. So that's this code. This starts the webcam.
Oh, that looks a little bit difficult.
And we did that in the last workshop. And
Yeah.
then when you draw, when you classify the pose here, you have to pass the video instead of the image. So this line of code, in our thing, we have an image here, but now you have to put the video here. But I'll upload this one also to the glitch.
Oh, yeah.
I can try to run it now just for fun, just to see what happens.
Yeah,
I'll try to do
it locally as well.
Yeah, I have this one locally.
Yeah.
I didn't put it on glitch, but I can upload it very fast. Okay, now this is it. See? Okay, Yoga model loaded. It's crashing, I think. Yeah, there we go.
Because your camera is also on in Zoom. Oh,
I'm a goddess. I'm a tree.
Nice.
Yeah, of course, now it's very glitchy because I'm not far enough away. It doesn't see my whole body. But the code is the same.
Yeah, and when you were working on this, because I see now you did this locally, was there any reason you started working locally rather than on an editor?
It's faster.
Yeah,
it's faster.
Like the model runs faster.
Yeah, everything goes a bit faster. Yeah. That's the only reason.
Yeah. Okay. Cool. I think we've made it. I am quite pleased with my results.
Yeah, I'm happy you got it working. I hope you're not the only one. Yeah.
Yeah, exactly. I'm curious to hear. Maybe we can do a quick checkout. I mean, because we did a quick check-in in the beginning as well, because we're such a small group. So maybe it's nice to do a little checkout if people are up for that and just see. I don't know, how do you feel? How far did you get? What did you learn? What are you still confused about? Just a little to round it up. I think that would be nice. Sophia, do you want to go first?
Yes, I can go. Yeah, these last two parts I was only following, not really doing, but it was so excited to see because I was like, okay, we have this model, but how they get the numbers? And it was so good to see your explanation how we can do that. But I was curious, like when you have 100 pictures, you do for each of them manually, because you said there are other ways to do, but yeah, it's crazy to think like it.
Yeah, you can't do it manually. Ideally, you have thousands of pictures.
Yeah, exactly.
Or even 10,000.
Okay, but to create to develop to render all these codes, it's
you have to find. Yeah, you have to create an algorithm that just does it all automatically.
Okay. Another level.
It's not super hard, but
yeah, it's like writing. You know JavaScript, Sophia. Maybe I'll ask you for help. Like just writing a loop that goes through images in a folder instead of uploading an image.
Yeah.
I don't know. I think if
you could even in this one, once it has found the numbers, you can say automatically do the next one.
Okay.
Yeah.
Nice.
Instead of that, you have to click.
Yeah. I would have no idea how to do this thing of assigning the name of the folder to the label, but that
maybe. Yeah, it's we can talk about it sometime.
Yeah, this is definitely more advanced. Yeah. Nice.
How far did the other people come? Was there a point where you were like, okay, now it's too much?
No, I think it was super interesting, everything, but at the second step, I get lost. I mean, I follow a bit, but of course, if you have to follow the video and also write it, you take a while. So at the end, I say, okay, maybe I can just follow, understand, and when the video will be uploaded on YouTube, I can rewatch it and fix all the things that didn't work well. But I mean,
Okay.
was super good.
Cool. Thanks.
See you.
Yeah, we can upload all the finished code, so you can see everything. Yeah. Actually, it is online, but it has all the strange names, right? So I'll make a list where you can find everything.
Thanks a lot.
No, thanks for joining.
The video, the recording will be online, right?
Yeah, we'll upload it on our YouTube, which Sophia is nice enough to always help us with. So we have a recording of the whole thing, and we'll put that on our YouTube channel. So yeah, we'll post it on socials. Like, you'll know if you follow us anywhere, you'll know when it's online, and you'll find the link.
Okay, cool. Yeah, thank you. No, it was super helpful. Just as a good introduction to machine learning. Yeah, I think I followed up until most of the iris parts, but then once I got to the yoga, I stopped. I dropped off a bit.
Yeah, yeah. I think it's also because we were this is part 2, right? So the pose part we also did in part 1. So maybe I assumed a lot of knowledge already, but
Yeah,
you can still try it. Yeah.
Yeah, exactly. There's
Sorry?
the recording, and also Veronica is making some blog posts now that are based on these workshops. And those can be also really nice, maybe to have like the video and or the blog, you know, and then you can follow sort of at your own pace. You'll have a lot of tabs open. But then you can just do it like, you know, really one step at a time and tinker around and stuff. We'll publish them. Well, we'll start publishing like this or next week, but then this one from today, it will be a bit later. But yeah, then you can always watch that back. And then because you've been here, it's going to be much easier also to follow along with that. So it's just the start today. Also, if this was your intro to machine learning, I'm like, wow, that's a lot.
Yeah, no, that's already quite a lot. If you followed the first part with the iris, I think you got a lot of useful knowledge, I hope.
Yeah.
Okay.
All right, and anybody has closing remarks, feel free to add. Otherwise, yeah, we'll round off for like half an hour over time, but I'm very happy that we could see the last step, because it's just like bring it all together.
Yeah, it brings it all together.
Yeah, exactly. So that was really good. Thank you so much, Erik, for doing this and for doing both of these, actually. I know you're already doing a lot of this in the day, so we really appreciate you also showing up for us.
No, it's cool.
To work to teach more of the world how to code. Really nice. Thank you.
No problem. It's fun.
And for yeah, for supporting the community and for being, you know.
Yeah, sure, of course, always. Yeah, I think it's great fun to do so.
That's good. Well, we too. So maybe we'll do one. And we'll just
we can find a new project.
Yeah, exactly. I'm gonna keep developing this one though, because I'm quite well, because I also do yoga. So
yeah, that would be great. Yeah, absolutely.
And yeah, maybe I'll share it somewhere and then
cool.
see how we go with that. Lovely. Then yeah, thanks everyone for joining. If you're not familiar, come hang out with us on Slack or on Instagram or in the newsletter. I don't know, we have a lot of channels, so you pick your favorite platform and however involved you want to be. I think this will also be the last workshop for this year. We're doing a social sort of hangout thing later this month. So it will be just to like meet other people who are into like AI and design or, you know, creative coding and these sorts of spaces. But it will be just like a chill networking thing. So no coding, not lots of information. So more like networking and just socializing rather than really, you know, on content. So if you want to join that, you'll see it come by. And yes, thanks again for being here, and keep us updated on your progress if you do end up also making more stuff with this.